All right. Hello, everyone. I see there's two people watching. So to the both of you, good afternoon or good evening, wherever you may be. So today I am going to talk briefly about designing software. So we're going to talk a little bit about architecture, and we're going to talk about the steps we should take to get AI to help us design what we want to build. So one of the sort of key principles that I have is, and this used to happen all the time, when I start talking to a chat agent, the chat agent immediately dives into building something. It doesn't fully understand the problem yet. I haven't really explained what it is that I'm building. I just said, hey, I want an app that does this. And all of a sudden it's starting to work. And that's okay for a very rough proof of concept, but you're going to end up with features that you're not necessarily looking for. These are things that you're burning money on because it costs to build, but at the same time are not features that you're going to keep. Additionally, I don't think we take enough time to review the consequences of our decisions around architecture. And so it's easy to say that, well, AI built it, and so it's for AI to figure all this out. But the problem is we established in an earlier stream that the way we build software hasn't changed yet, right? We're still building software in exactly the same way. The person who builds the software changed. It used to be physical, actual people, and now it's what we call AI, which is not really AI, but we're going to use that term. And so even though it's able to keep up for the most part, at some point it's going to become unmanageable. I worked on a project a few years ago where the software was becoming unmanageable. So basically every time a support request came in, the developer who was doing the work would just basically write an if condition into the code to manage whatever problem he was having. So if he was having a problem with a particular file, he would say, oh, when you see this type of file, do this, otherwise go and do this other thing. And so over time, if you can imagine, this becomes condition on top of condition within a condition, and yet more conditions all around. So it's very difficult to follow the code. It's very difficult to figure out what's going on and where. You have to be able to see the bigger picture. In other words, you have to be able to look at your software from not only what you're delivering to the clients, but also from the infrastructure perspective and how you're going to support it long term. Because obviously the goal for all of us is to build something that lasts, build something that people use, and that makes us ultimately some money. If that's what you're going for. At one point, I think I'm going to do a stream on business models. And for example, my model is a bit different, but it doesn't mean that the software that I build is going to act in a different way because it's not meant for the masses, for example. I still need to be able to support it, and I still need to be able to work through different scenarios where if somebody wants an update to that software or a new feature, that it should be able to be written, and I should be able to understand and follow through roughly the code paths of how that feature comes together. And so that takes us to architecture. And this is something that I've shown before. By default, if you let AI deal with architecture, it's going to basically pile everything together in one project. So it's going to say your infrastructure, your client, which is how we view things, your business logic, your database layer, everything live within this one piece of code, and everything has its own mix of functionality throughout the entire project. And an example that I gave before was that if you're looking for a first name and last name, the AI might create 3 separate functions because nobody told it not to. And so you might have get user for feature 1, you might have You might have get user 2 for feature 2, and you might have get user 3 for feature 3, which is pretty bad because it essentially in all three of these features, you're getting exactly the same two pieces of information, first name and last name. And of course, later when you want to add a middle initial or you want to do something else with that, you're chasing down all these different places where you're collecting the first name and last name instead of having a single source of truth for the first name and last name that's used across the different features. And it's not that the AI isn't capable of delivering this. It's definitely capable of delivering all of this. It's how it looks at it. In other words, if we didn't tell it to do this, if we didn't physically tell it to write one function and then use it across these three features, it doesn't know to do that. So it doesn't look to see what code is already available, and it just simply creates, get user 2 or get user 3. And the way it arrives at get user 2 or get user 3, not because it sees, I see something's already created there. It just might create an error when it's creating that code that says get user. It says, I can't use that name. It's already taken. Let me create get user 2. So the point being is we need to explain to AI these types of things. And the goal that we're trying to achieve is we want to create a N-tier architecture. And an N-tier architecture is basically at the most basic level is three levels. You have a database level, you have a business logic level, and you have one or more clients. And I say one or more clients because you could have a web client, you can also have a mobile client, and you can have clients like an API. It really doesn't matter. It doesn't matter how you want to show that information, so long as the layers that you're using below here are all consistent. And a lot of the times when I write applications, I do have these 4 layers. I don't really need to make it more complicated than that. I'll have a database layer, which deals with all of the queries that go against the actual physical database being used by my application, if there is one. Then there's an infrastructure layer. So for example, if I'm sending out things like emails, then the infrastructure layer is the guy responsible for that. We can also do things like different business logic, which, for example, if you need to add certain things together, or even something as simple as storing at the database level, we might store the first name and last name as separate columns. But by the time we get to the business layer over here, we might want to put them together because we want to have a full name instead. And so those types of things are handled at these different layers. And this is usually the UI, which includes your HTML, CSS, maybe JavaScript. I don't rely on JavaScript heavily, so it's not always JavaScript. Then if it's a mobile client, maybe that's Flutter and Dart. If it's a Android application, maybe that's Java or Kotlin. If it's an iOS app, that might be Swift or whatever language you're writing it in. And so that's typically the breakdown. And then each one of those layers, which is another important thing to consider, is that each one of these layers actually has its own set of routines. So they're not commingled or combined together like they would be by default. So here we have logic and infrastructure and database and UI all mixed up in the same project. Whereas here, they're all separate. And the benefit of that is it's easier to look through those layers and make sure you have specific responsibility across each one, and then be able to write your features in a way that they cross those different layers as they're built up. It's easier to make changes, for example, directly here at the database layer without having to touch anything else. In a scenario like what we have here, we may have to touch multiple things in order to resolve a particular issue. Not only that, but it might take us longer to find and figure out what that problem is because of how everything is put together. So basically, this is a bowl of spaghetti, and this is what you're shooting for if you want to have code that is maintainable, is something that you or other developers can support, and ultimately that potentially is sellable. So for example, if you're in the business of building an application and then saying, oh, I'm going to flip this, I'm going to sell it, like if it's a black box that nobody understands because it was written by AI, then nobody's really going to buy that. At least I certainly wouldn't. Additionally, the other thing to consider is that Apple, at least Apple for now, probably Android will get on this bandwagon as well at some point. But Apple right now is starting to crack down on AI written applications. So if they don't follow good coding practices, chances are they're going to be flagged and they're not going to make it into the Apple App Store. And so I think it's important. I think that's a sign that says, hey, like, you know, it's time to do things more correctly and rely less on what the AI thinks. And so how do we get to that point? What is it that we need to do to make sure we can build software that is actually something that will pass Apple's inspection and that we can support? And again, I've shown this before on the first stream, and the idea behind it is that you can use your AI agent in a couple of different ways, and I almost call it a framework or a guide. I don't really know what the proper name for it is, but the idea is that we can use the agent as a decision maker. And so here, if you're not a developer and you don't understand what layers you need for your application, or you're working in an environment and a language that you've never worked in before, and you need some additional guidance, so using AI to help you make those decisions, I think, is a valid step, because it knows all you have to do is ask the right questions and guide it in the right direction to make sure that it gives you the answers that you're looking for so that you can make the decision. Here again, it's an important concept of human in the loop, or HITL. And basically, we're making the decisions. We're not leaving these decisions to the AI, but we are getting the guidance that we need from AI so we can do the right type of assessment on each situation and make the correct decision. Obviously, you know, when we get to the build stage, AI is what we're using to build applications. And here too, it's what's doing the work, and it's doing it faster than we could, especially if it comes to languages that we're not familiar with. And that's fine, but it's doing that based on the decisions we've already made. And finally, I have learned quite a bit. For example, I was working with CI/CD pipelines, and I look at, you know, different ways that it incorporates things, and I look to see how it's doing what it's doing, and reviewing that code, the YAML code that it's producing, and why it produced it in the particular way. And then I start to ask questions. I'm like, what does this line do? Or why did you pick this image versus that image? So there's tons of ways that you could interrogate and ask the AI to explain what it did and why it did it. And it should be able to collaborate with you relatively fully and give you those answers. My, of course, experience comes from working with a couple of different solutions. I work, of course, with Cursor. I work with Claude Code. I've recently started working with Android Studio, AI Studio. Android.com, I think is what it is, or google.com, which builds Android apps very, very quickly. I actually have a couple of apps that I'm getting ready for the market. And then I also have started working with Codex. I think of all of them, I like Cursor the best because I can integrate Cursor with a lot more things, being that it's Visual Studio Code based. I also like the fact that I can have Claude Code and Cursor work on the same solution at the same time. I know that sounds kind of crazy, but there are certain things that each one is a little bit better at. So sometimes it's helpful to have both of them in place. And I guess maybe because I've used Visual Studio Code for so long, that solution just seems to make a lot of sense to me. All right, so where are we going with all of this? So the hard rule, the hard rule that you have to first agree on is that the AI leads, but you make the decisions. You decide. And you want the AI to explain things in plain words. So you don't want it to give you, especially if you're not technical, you don't want it to give you very technical answers about why it's about to do something in particular, but you want the AI to explain itself and ask you to make the choices. It should give you the pros and cons list, and we'll talk about that briefly when we talk about ADRs, or architectural decision reviews, which I'll talk about briefly in this presentation. I think every topic that I have here today deserves its own stream, and I plan on doing that. I am going to really kind of glaze over wireframes or mock-ups. I'll talk briefly about it, but not going to get into detail of that today. But the idea is, again, like, you know, your basic rule of thumb is AI leads, you make the decisions. That's an important distinction. If you make that distinction going into a new project, you have a clean slate, you're going into a project, this is how you're going to handle it. I think that makes right off the top, a big difference, because if you get it to, if you go in with that mindset, you're going to ask it questions. You're going to say, no, don't build yet. Let's figure all this out first. And then when I have all my answers, then we can start actually implementing things. So to set up the project, you basically start a new prompt, and that would be in planning mode. Today, I'm not giving you any specific prompts, and I think for a couple of reasons. So I thought of just including some prompts and maybe even doing a demo using Cursor. But these things do take a little bit of time. So, and you know, this goes back to junior developer mindset as well. So when I was a junior developer, one of the things I just wanted to do was to write code. Like, that was just the thing. And you can't always just jump in and start writing code because you have an idea. You need to draw out all the different possibilities of that idea. You need to document it. You need to figure out how you're going to write that code, and then you should start writing that code. It took me a couple of years to change that mindset, to get into that mindset where I say, no, I'm not going to just jump into it and start doing it. I might have done some prototyping and like say, oh, I wonder if I could do this, and I'll just, model something and try it out to see if it would work. But I wouldn't necessarily start working on the feature without fully understanding what it is that I'm going to deliver and how it is that I'm going to do it. Like, I had almost like a checklist or a to-do list of things that I needed to get done in order to move this feature forward. And so that might have been like, hey, edit this file and add that, edit this table and create these columns, modify that stored procedure, add that to this database layer, and one step at a time, I would increment and go forward. And so this is kind of like what you want to do with AI. So being working with teams and working with developers for years now, it's just, I guess, one of those things that I picked up in terms of how developers think, how I think as a developer, and what we need to sort of convey to one another. So if I'm delivering a feature that I need them to work on, I treat the AI very similar to the way that I would treat junior developers, knowing that a junior developer, given the feature, is going to jump immediately into writing the code. I'd want to sit there with that person and question, well, how are you going to implement this? Like what specifics are you going to do here in order to pull this off? Obviously, some features are very easy and they don't require that kind of hand-holding, but a lot of things do, especially when it's a new project and you don't have anything built. You need to be able to put together that architecture and design before doing any of the work. So the idea is you want to create a prompt. Your initial prompt for the AI should be in planning mode. Both Claude and Cursor have this, and this is what I would use. And in that planning mode, you're essentially going to ask the AI to interview you. You're going to say, I want to build an app that does this. I want you to ask me one question at a time in order to better understand what it is that I'm trying to do. And then we're not at this level, and this is something that goes into the prompt. At this point, you are not creating any code. You're only creating documentation, and you can put it into this folder here. So I usually have like a documentation folder that contains all of the markdown documents that accumulate, which are part of the planning phase. And there's quite a bit that actually gets accumulated. So it's I think it's an important part of working with the agent. And so as you go through each one of these iterations and you're starting to see plans come up on the screen, you want to make sure that you review that work, you review the understanding of the AI, and you might have to adjust what it is that you said to them. So for example, you say, oh, like the summary of this feature is wrong. Here's what it actually should be. So go ahead and revise that and make it all work. And, don't write anything other than this documentation. Again, that's an important part of that step. So then the next thing that I do after this interview, right? So we have this interview here. Once that's done and I've read it over and I'm happy with the results, I'm going to ask it to start planning the work. And the way I like to do this is something that we're going to talk about next, is user stories. And so this is something that's been around for years as part of the agile development methodology. And I like it because no matter who you are, you can understand a user story. It does not dig deep into the specifics of databases or layers or anything else. This is something you are going to establish as part of your planning phase. But the idea is that you can define the different features that give you some sort of a value. And when you phrase it in that way, they're easy to understand. You need to give them acceptance criteria. And to me, that's a lot of the work planning. As part of this, we'll also do something called ADRs, where the AI actually helps you make architectural decisions. In other words, how many layers do you really need? Do you need 3 layers? Do you need 4 layers? What goes into each layer? What are the boundaries of each layer? Why did we create these particular layers? How is that going to be useful going forward? Like, what's the downside of having these layers? Also, of course, during this phase is you would do what I talked about last week, which is create the various guardrails that you want to put in place to make sure that the AI doesn't overstep its bounds. So, for example, no looking at .env files, which contain secrets and environmental variables that you don't want it to know. You also don't want to check those into your Git repository. So having a proper Git ignore is important at this point, and the AI can produce these files for you. Additionally, you may not want it to work with Git or work directly against the database. For example, I typically don't let it work on either of those two things. I prefer to manage that myself. And so as a result, those become rules that are part of my planning phase. Less design, more planning, but they're part of every project that I work on. All right, so now if we take a step forward, I just mentioned the fact that we would have something called user stories. And so a user story is a short description of something that the user wants to do with their software, written from the user's point of view. So it's not written from the system's point of view. It's not written from a screen perspective or a database perspective or a technical feature. It's written from the perspective of, hey, I'm the user. I want to do something, and this is what I'm doing. So in many cases, if you look at a user story, it looks something like this. It will look like that. As a, let's say, regular user, I want to perform some action, and then you want to describe that benefit. And it seems short and to the point, like if it's more than a paragraph of stuff, more than really 2 or 3 sentences, I think you start to run into a problem. If you have to use the word "and" anywhere, then that's probably 2 stories rather than 1. The goal is to break it down to these relatively small chunks. In other words, you really do want something to be this small, because something this small is something that the AI can produce relatively easily, accurately, pretty much every time, even if it has to look across layers and build it, across like 10 different, layers within your application. It should not have a problem doing that. But if you give it too much information, you run the risk of it getting confused, hallucinating, running out of context space, or any number of other things that could go wrong with building something. Because remember, even though we don't look at it as such, a lot of what we talk about in this AI space is the fact that it's really the next best guess from the perspective of how it figures things out. So it's not necessarily going to get it right each and every time. So here's an example of a story that is good to go. And basically it says, as a user trying to build a new habit, so this would be for a habit tracker. I want to mark a habit as complete for today so that I can see my streak grow and stay motivated. So that is your story. And so here, that's pretty obvious what you want to do. And then the way we keep the AI honest is with acceptance criteria. So the acceptance criteria allows you to specify the different things that need to happen for that story to become good to go. So in other words, by the time AI builds that story, this acceptance criteria should all be possible within the story. And so here we have, we want to be able to tap the complete button on a habit to mark it complete for the current day. And then, we want to somehow distinguish that from a complete one, from an incomplete one rather. The streak count for that habit reflects consecutive days completed. So maybe there's a counter there somewhere. Maybe we see a row of these or stars or, however. Tapping complete a second time on the same day does not change the streak or create a duplicate completion. So that's an important distinction. And you want to make sure that it's written to a database, because otherwise you're going to lose it. So that last one is the completion state persists across app restarts. Now, technically speaking, I could probably find 5 or 6 more acceptance criteria items that I could fit in here. So for example, what if I tapped on one by mistake? I'd want to be able to undo that or untap it. So there should be acceptance criteria for that. And then you could give all of this to an AI agent, and you could either be explicit and explain to it exactly what the UI should look like and how things should work, or you could let it decide. This is small enough that if you already established what the UI looks like and how things should function, that it should be able to pull this off without much grief. Now, I will say a couple of things about this. So first of all, and this is something that I'm not really going to concentrate on in this presentation, but I talked briefly about wireframes and mockups, right? So this guy here. So AI is really, really good at creating wireframes and mockups. And you don't necessarily need to go crazy and build stuff, using the real frameworks. You could ask it, for example, let's say it's a mobile app. You could ask it to build a mockup using HTML, CSS, and JavaScript. You could also, if it's a website, you can ask it to build a website without the database layer and possibly without, the different functionality in place, but more of as a visual guide. And it'll do that. And so if you have the mockup, you've already probably solved a lot of the things that go into this acceptance criteria. So the acceptance criteria to some degree is based on what the screen looks like and how it behaves. And so by the time you have this story written and you have a mock-up in place, you should be able to get to this acceptance criteria. And the steps or the order in which that I do this in is, one, I'll have the AI work with me on the story. Once we feel that the story is good, and what I did is I wrote a skill that both Claude and Cursor use for writing stories. There are also numerous skills out there that you can download and incorporate into Claude or Cursor or Codex to help you write these and make sure that they're in line. One of the things to watch out for with the stories is that they should be small. I use t-shirt sizes, so extra large, large, medium, small, extra small. So you want stuff to be extra small or small, not medium or larger, unless medium would be like the top end of a story that I would accept. Now, that's not to say that a story that's extra large or large is not valid. It's a starting point from which you can create additional stories. So if you do end up with something that's extra large or large, and you would know because you're talking to your AI agent and you keep asking it, is this a large story? Is this an extra large story? Where do you feel it fits? It should reason enough to tell you that, yeah, this is a large, we should break this down. And it'll probably recommend how to break down those stories. At least that's been my experience. So you could start out with something like, hey, build me this entire thing. And then before you know it, you have like 12 or 15 different smaller pieces that you can actually manage and work towards. So then after I have the story, I would probably recommend doing the mock-up. And the reason being is because the mock-up is enough to start working on the UI. And you may not know exactly what the UI should look like, but based on the story, your AI agent will have a decent idea of what to build. And so you can give it some creative freedom and let it work and create something for you. And again, you want to iterate over that mock-up just like you would with a regular application and get it to tell you and get it to improve it over time until you get it to the point that you really like it. At that point, you could either ask it for the various acceptance criteria based on the mock-up and the user story, or you're jotting these things down as you go. In fact, you could tell the AI to keep track of the acceptance criteria as we build this particular mock-up, so that by the time you have the mock-up and you have the story, you also now have the right acceptance criteria. All of this is documented in that documentation/stories folder, and then you can proceed to the next step. Now, why stories as opposed to just telling it to write a feature across multiple layers? And the reason being why this works is that if you tell it, well, when I hit this button, I want you to write a record into the table that says, for today I completed this task, and then do the calculation to see how many days in a row I've done this task and return that data back to the front end. You'd have to really explain to it like, hey, like I need you to write this query, I need you to do this, I need you to then, bubble up this information because this is going to tell me something. And it's not the way we think, and it's not the way AI likes to think. So by giving it a small thing to work on, it's probably going to get it right on the first try. If it has rules in place that already tell it about the different layers and things that we're using, so if we have database layer, logic layer, UI layer, all those things are in place, you can make sure that it's following that work properly and doing it correctly. And finally, it's understandable. It's understandable for you, and it's understandable for the UI. So by having the mockup, by having the acceptance criteria and the story, you have everything you need in order to, I would say, 9 out of 10 times be successful with a feature on the first try. Now, you could say, well, wait a minute. Like, if I have like 50 features, and if I break them down into stories, that's probably 150 stories. And then if I have, these 150 stories and I'm working on each one individually, it's going to take me like a week to build the software, and I really need it today. Well, yeah, it might take you a week. I've built whole systems with multiple layers and, some serious complexities in 4 to 6 week time frames. I rewrote one application in literally like 3 full days. So, 24 hours. But the point being is that it's still going to be much faster than if you attempted to do this yourself. And what you're going to get out of it is something that you will be able to understand, at least understand better, and be able to trace back how every feature sort of works. So I think it's an important step. So one of the main rules is that there's absolutely no development work until, for the AI, because the AI is ready to go. It wants to write code right from the get-go. So no dev work is done until the story is complete and accepted. So in the document that stores this information, the acceptance criteria, the story itself, there should be some sort of a header that basically says that you've accepted this, or it needs revision. And so anything that needs revision or isn't complete or is being worked on, whatever status you want to give it, that's totally up to you. It's not something that's ready for development, but something that's in a accepted state means it's in our sprint. We're ready to go. And you could do this as sprints. You could do this as just tasks on the page. However you want to look at it. Like, to me, stories are just one after the other. I do ask the AI to logically group them and order them, so I know which ones I'm working on first and why, and which ones are necessary afterwards. So in other words, it's pointless for me to build a page around, editing habits if I don't have a page that shows those habits to begin with. So I need to make sure that I build that page first and then build the page that allows me to edit them. So that takes us to the next piece, which is the architecture. And architecture seems simple on the surface, but has a lot of implications for what we do. So again, going back to my first stream, I remember there was the YouTube video with the guy who built 35 things, and like 3 or 4 of them survived, everything else died. And I question why those things died. It's possible that some of them died because they're just bad ideas. It's possible that some of them died because nobody used them. But it also is very likely that some of them died because they came out to be too expensive or had problems that couldn't be solved. And so that takes us right into the discussion around architecture, which again, I still think that there's a much bigger, deeper discussion here than what I'm going to do here today. But the idea is we take a lot of things for granted very quickly when we're building software. So it's possible that very simple things that we want our software to do have a huge implication for how those things come together. And to give you some examples, so for example, let's just say we want to do authentication within our app. And if we wanted to do authentication within our app, there's a couple of different options, but none of them are free. And what they require is some sort of a centralized server into which you could store these logins. Maybe that's Google, maybe that's Facebook login, whatever you want to use. But somewhere there, you have to have a table that identifies the user, identifies their email address, gives them some kind of a unique ID, possibly manages some permissions for that person. And so just by saying, hey, I want authentication, you've created some infrastructure for yourself, stuff that you need to maintain going forward or pay for in order to be able to work with the app. So some of the things that these decisions have is, obviously, we can have added costs, right? So databases, authentication, identity servers, storage for uploads, storage for user data, ability to send email to people. All of those things have costs. They may be insignificant to begin with, although even open source databases in the cloud tend to be expensive. I'm sure there are deals, that, 12 months, you get something for free. But then after the 12 months, if you want to look at something in a future forward way, it could be very expensive. Like I haven't seen any database that is inexpensive out of the gate, just as an example. And then there's potentially additional work and complexity that you're adding to your project. So what do I mean by that? Well, let's just say you're talking about using Amazon Simple Email Service. Well, Simple Email Service requires a user to be created. You have to get your domain approved. You have to monitor for spam and problems. So there's this infrastructure layer that now you're dependent upon that you have to maintain and work with. So obviously, some of these things may add to your support issues. So in other words, what if you start to collect some data and store it in a centralized place? All of a sudden your user says, hey, I don't see my data anymore. Now you have to go figure out where in that centralized place that data is, why it's not showing up on their device, or why they can't see it. All those things start to come into play. And then, of course, you also start to work with things like GDPR or the California Privacy Act, where you have to make sure that if you're storing client data in some way, that you do that securely. And client data is anything from email address onward. So if you're basically going to collect data, you need to make sure that your security is up to date. You have to have the ability for those people to, for anybody who comes along, basically say, hey, I want to be deleted. You want to allow them to, or you want to have a process in place to be able to delete them. And you want to be able to acknowledge why you're collecting that data, not just because you want it, but you have to have a reason for it, especially for something like GDPR and California Privacy Act. So you need to have more information around these different things as you're building your product. And so what you could do with the agent is identify your best options. So in other words, it's not so much about, hey, I think I'm adding authentication to my project. It's let's talk about the different options around why I think I want authentication and whether or not that's really valid. And so ADR is architectural decision reviews or records, to be more precise. And it's something that I saw a few years ago while working for one of the companies I worked for, GenRe. They used ADRs pretty frequently, and it's also something that I saw over at used at Amazon. So Amazon has Amazon Web Services has a pretty big section on ADRs, and you could go deep. There are books written about this, and I think it's a great way to make decisions. I've used it since I've worked at GenRe for numerous things, and I think when you work through an ADR, it really kind of comes together and gives you a clear indication of why you're choosing something and what reasons are. So for an ADR to be efficient or effective, you usually work in a group with a group of people, and everybody has their say, the pros and cons, the various options that are available for this particular decision. And so here I have a pretty simple one that is just around authentication for version 1 or an MVP of let's say this habit tracking app. And so first you specify the context, and here from a context perspective, we're saying we're building this habit tracking app, and it's for solo users, so it's not something for multiple people to use at the same time. So from an app perspective, it may not make sense to have a authentication at all. And so the decision was, and we didn't come to this decision until we sort of looked at different alternatives and the pros and cons of each, but the decision was that there won't be authentication and there are no user accounts. So the data just lives on device storage, and if the app gets popular, then for whatever version 2 is above the MVP, that's when we'll do the authentication. And there were specific reasons that were cited for this. And so the reasons are that, zero backend to run because we don't have authentication, no PII to protect, no GDPR requests, no password reset flows, no account deletion flows. Those are all huge savings for this particular app. And then, you want to make sure that you track to see if people are actually complaining that, hey, I lost my data because I switched devices, or whatever it is. And I do think even a local sync option is much easier than trying to do something with a centralized server. So if you're just starting out and you're looking for ways around avoiding some of these expenses, I would definitely use ADRs to figure out what it is that you actually need for the application that you're writing, because you may find that you don't need databases, you don't need an infrastructure in place to do the things that you want in an MVP. There might be other solutions for your specific problems to allow that. And so then there's the effects of what we're doing and how, and then there's a validation and possibly links to other parts or other ADRs to make sure that the picture is sort of complete. And these are nice to keep in something like Obsidian, or if you open your documentation folder in Obsidian and it's all cross-linked, you can see all of the different links and how they behave and navigate from one to the other. So it makes for a good way to navigate and work with documentation. So at least I like that. And those are the basic concepts that I wanted to get across today. In other words, it isn't rocket science, but you want to take a little bit of time and think through how you're building things. You want to instruct your agent not to start building stuff, but instead work with you on the full plan. That full plan will typically include all of your user stories, if that's what you want to use. If you just want to document all the different features and not necessarily use a story format, that's fine too. I think I think the AI agents understand stories much better than anything else because they've been trained on it and they understand that Scrum methodology pretty well. But it doesn't have to be that way. But bottom line is you want to outline all of your features. Once you outline those features, the next step is you want to build some mock-ups. And a mock-up is just another project within your whole solution. So your whole solution might be all of your different layers, your UI, all of the different components that make up your application, including the documentation. And mock-up fits somewhere between documentation and, like a working app, if you will, because AI will use, for example, NPM and Node to host it. And you will see like if it's a mobile app, like a mobile outline. So you can also click on things and try them out. So it's not a picture. It's a little bit more interactive. But you could really dial that in. And once you have that mock-up, once you have the story and you have your acceptance criteria, whenever you start a new agent, you say, hey, you already know the rules, you know how the structure of our application is going to be, you know how all of this is put together. Here's the story, here's the mock-up, and here's the acceptance criteria. Ask me questions about that, plan it out. Then you review that plan based on the story and the mock-up and the acceptance criteria, and you let it do its thing. And if your stories are truly extra small or small, which is hard to think about, but that's what you want to think about. If they really are that small, then 9 out of 10 times it'll probably get it right. And every time it gets it right, you check that in, you push it to your main branch, and you go do the next one until you run out of stories to do. And hopefully that by the time you do run out of stories, you've looked over all of the different implementations that the AI has done. You've tested all of that work and you are ready to put it on a device or on a website, web server, and try it out to see how well it works. So I do think it's a good way to work. And so now some questions. So if you're watching this, and I don't know if anybody's watching this live or if everybody left, but if you do work with this, I have a Discord server set up. It's the Control-Alt-Create Academy. The link for it is right here. You are welcome to visit it and sign up, introduce yourself, and then tell us how it is that you're using AI. Do you do any kind of workflow like this where you actually plan things out ahead of time, or do you just jump in and start writing code immediately? Do you consider infrastructure and consider costs along the way and consider services that you may have to buy and utilize in the effort of running this application? Do you consider their maintenance and the support of all of these different things that you're creating? So definitely join the conversation, and I will see you next week for another session where I think we might talk about business models, although I haven't fully decided yet. Anyway, until next week.